Okay, so we're going to try to find the formula for this sequence given the first few terms of this sequence and assuming that the pattern continues onward. So with this one, we have to break it into subcomponents. That's the general strategy that you want to do. So the first thing you want to notice is we have positive, negative, positive, negative, positive, negative. That tells you we're going to have to use one of these things where you have an exponent. But we can't just let the exponent be n, because if we let it be n, then we would start with a negative first term. And we don't want to start with a negative, so let's just add 1. So that our first term has an exponent, which is 2, that squares it, the negative becomes a positive, so that's good. But then on the next round, it's going to alternate back to negative. So that's why we do this. Okay, the next thing we want to notice is, what do we have in the denominator? In the denominator, we're adding 1, obviously. So that's all we need, n plus 1. Because our first term that we plug in for n is always 1. And that's going to give us 2. And then when we plug in 2, that's going to give us 3, and so on. So that's good. The next thing we want is what's going on in the numerator. It seems that these are all squares, 1, 4, 9, 16, 25. So since this is a sequence that we're talking about, where this becomes 1, then 2, then 3, then 4, then 5, all we need is to square it. And you can check for yourself, that's going to work out. So that's what this sequence is. The sequence equals this.